So welcome back, everybody. Hopefully you all can hear me okay and see my screen. Let's see if I can see my screen, so I'm hoping that means you can. Anyways, so for this one's to be a little different. Last year I did kind of a web app attack scenario. This one's somewhat the same, a little different. So this time around, we have a file on a system. For those who don't know Linux very well, usually the /etc, so slash being the root of the file system and etc being the next folder, has a file called password.txt. So this is just kind of an example of what we can do to, read that file content. This machine is meant to be somewhat difficult. So the reason that I would say that is because it's preventing us from doing a lot of things we would normally want to do. So if I'm running a SQL exploit, maybe I just want to know what each letter is, and I'll just tell it to use Python to do that. But essentially what we're trying to do is use this new endpoint and figure out if we can get it to do what we want. So actually what I'm going to do before I jump into this is I want to show you what we see. What is the name? That's there it is. So before we get into it, kind of want to show you what we're working with here. You share this. Share. All right, so it doesn't look like much, right? But this is the host we're attacking, right? So if we come here, I already did all the enumeration for us, but this is the host. You can see here we have a standard default page. Usually this tells us that we're serving some sort of web content on this machine. And if you poke around a little bit and you do like a brute force of any kind, you're going to find this, right? So I mentioned PHP earlier. So PHP is a server-side language. And usually what this does is it lets us, what's it's supposed to do is it's supposed to let us ping a host in the environment. So you can see we got an OK response. If I give it something that doesn't exist, like this, which is not valid, it's going to sit there and hang. You can see that there. But that's okay. That's kind of what we wanted, right? So this is going to hang forever because it's not a real valid host, right? So, but essentially what we're figuring out is that this thing lets us ping something else in the environment. Well, how does it do that? Well, we can make an assumption, right? Either they wrote the code for it themselves or they got lazy, which is what most developers do, and they use ping from the command line, right? So if you had a Linux machine or you had a Windows machine and you typed in ping and then the address, it would also ping it, right? So we're going to assume that they did step 2, they were lazy, and so this actually gets us access to the operating system. Now, there's a bunch of different ways that we can prove this or test this theory, which we're not going to get too far into because I want to get more into the code itself. But essentially what we're going to do is we're going to start programming. So let me open up my thing here, my demo script. Perfect. All right. So the first things we're going to need is we're going to do some imports, right? So we want to import the sys package. This is just so we can use system operations. We want to import the request package. And this is what's actually going to make us or allow us to use requests like HTTP requests or HTTPS requests and make those requests, right? And then we want to import time. So the reason we want to import time is because what this actually is this is a what do they call that? A blind SQL injection, right? So essentially, we don't really get the immediate response. We know based on time whether or not this failed. You saw when we made that request to a 1000, which is not valid, it took a lot longer, right? It hung for quite a bit. So what we know is when something is valid, it's really quick. When something is invalid, it hangs for a very long time. Now that time could range. That's not important. What matters is we know what that time is, so we can effectively change it, right? Or we can use that as a way of determining whether or not our previous request was working or not. We're also going to make some aliases for this. So we're going to rename sys as S. We're going to rename request as R. We're going to rename time as T. That's just for me, just because I prefer to do it that way. It's a lot shorter. And so when we now call like S, right? So it's going to give us all the options we have, right? So I can say, what are the arguments that are supplied to me? I can tell it to exit, whatever I want to do. So S is just sys, R is request, T is time. All right. So the next part here is we're going to get our hosts. We're going to set a couple of variables, right? So we have initialize variables. We're going to do found. We're going to set that to false. And we'll go into what found is in a second. We're going to go with character position. We're going to set that to 1. Actually, found is 0. Sorry. So 0 is still false, but there's a reason we're going to do that, and we'll get into it in a second. We'll go with partial string. And then we're going to go into target URL, which in this case, you can see it's already kind of been written out here, which is nice, right? This kind of tells us to get it from the command line. We don't really need that right now. I'm actually going to change that for this specifically. Give me 1 second here to get the address again. Copy, That's we're going to go with HTTP. We're just going to use that endpoint that we found. It should be ping w dot or PHP, I believe. Or is it ping HW? Let me triple check that. Ping hw.php. All right. So again, this is that endpoint that we found that had that little field that we can input, right? When we make a post request there, we're just going to post it directly back to there, back to ping HW. So that's not too important. And we're going to say results equals nothing right now. We don't have any results. All right. So the next part of this, what did I just do here? There we go. Is we're going to create a loop, right? So we're going to iterate until we get to the end of the file, essentially, where we try every possible combination. So what we're going to be doing is we're going to say, we want to read this password.txt file. To read that file, we need to basically go over every possible character between lowercase a through z and uppercase a through z and all the numbers. And we're going to say, is the current character in this position this, right? So when we look at it this way, right, if we don't know anything about the file, we don't even know how long it is, right? We can basically say say these are all the letters in the file. We're going to say, is this character the very first character, lowercase a? And we should get a response back that says, yeah, true, right? That is a. So that's kind of what we're looking through here. Is we're going to create a variable that's essentially going to be all the possible characters we can use, and we're going to go over each character for every single entry. So once we get a, we'll move on to the next one. Say, is it this? We're going to do that for every single entry until we get the entire file, right?
Hey, Evan.
Yes.
Super quick. If you are wanting to share your screen, we cannot see it.
Oh,
so go ahead and share your screen one more time. Yep.
I am on it. There we go. Here's all my stuff. But yeah, the explanation still stands. I'll also write some notes in here so we can kind of get an understanding of what this is all for. Again, so this found variable is basically going to say, is this the right character or not, right? So is the character in this position correct? Question mark. The current character position is the current character being used. The partial string is the string that we are building using the guest characters. This is just the target of the host we're attacking. And then our result is going to be just a combination of like all that together, right? So that's just all of those. Now we will begin our loop. So we'll say while not or while found. Double check here because there's a way you have to do this specifically. Equals 0, right? So while not found, now we start iterating, right? So if we're going to say for character in, and then we're going to let it autocomplete that and delete the rest of it. You can see that I've done this a few times. Now it thinks it's smart. So for every possible character in the alphabet, uppercase and lowercase, and all the numbers, right? So again, we're going to go over each individual character for every single line. We're going to say the time is currently, we'll go with current time equals t.time, right? So we're going to say the time right now is t.time. That's going to give us the current time. And then we're going to say r, which is our request.get. Okay. And then we're going to give it the target URL, which is going to be target URL plus host, because remember when we put that into the URL, it said host equals and then our IP address. So we need to make sure we supply the same command. And we're going to put this here, right? So the reason we're putting this here is because in the bash system, whenever you put the semicolon, right, that means the end of a command, right? So essentially what we're saying, if we look at it this way, if we're in the bash terminal, it's going to say ping, and then it's going to get the argument from the host or from the URL, and then it's going to basically ping it a couple times and say whether or not it got to it or not, right? You can ignore all the stuff it's trying to add there. But this is essentially what it's trying to do. What we're trying to do is we're trying to make the argument, instead of making it an address, right, like 192.168.70.1, instead of making it something valid, we're going to exchange that with this. And the reason that works is because now ping is going to be the end of one statement, and it's going to do nothing because we didn't supply it an argument, and we don't care. What we want to do now is we actually want to make it do something for us, right? So we're going to say, instead of pinging, which is the whole point of this, right, we're going to cancel out the ping. We want you to open up Python, import time, right, like we did up here. Remember, this is on another machine. And then I want you to open up the password.txt file, read the first byte and then ask if it's equal to this character of mine, right? So that's essentially our goal here, is to cancel out the ping, make the target host open up Python, which I've already confirmed has Python, right? So there's a bunch of ways you can do that, and then make it read from there, and then confirm back to us whether or not that position is this letter based on time. The reason we have to do it based on time is because if we use it any other way, if we just say, is it equal to this, it's going to kick back, right? It's got some sort of firewall feature in there that doesn't allow us to pass SQL directly like that, which is another reason why even when we want to pass it Python, right? We want to say, hey, use Python. This is typically what you would do. If we pass it this, it's also going to reject it, because again, it's going to say, hey, this is trying to perform some sort of injection and it wants us to open up Python. We don't want that. So what we can do instead, and what you're going to see me do, is we're going to give it this, right? So it's going to be, instead of Python, it's going to look like this. And the reason it looks like this is because this means nothing. This is essentially just going to be an empty character, right? So what it's going to do when it reads this and it tries to compile it, or I guess execute it, it's going to delete this, which if you look at here, still says Python 3, right? So we're going to be adding this in several times. All right, so hopefully that makes sense. So we'll kind of go through with the rest of this now. All right, so we've got our host. We're going to add that semicolon, like I said. We're going to tell it to open up Python, but remember, we're going to do @ so $@ which is going to be nothing. And then the command that we want it to execute with Python is import time. So we have to tell it to give it the, we have to surround everything in double quotes. So we have to cancel the double quotes here. Could also use single quotes to encapsulate it, but that's not important. So we're going to tell it to import time. Again, we need time so that it can tell us how long it took, or like what the actual time was, and then it can sleep for that amount. Once it imports time, we're going to tell it to open the file that we want to attack, which should be etc password.txt. And we're going to tell it to read that file, right? So for some reason on this box specifically, if you wanted to practice with it, I could always supply it. You can't read any other file. It lets you read this file. It might be the user that it's given permissions. I don't actually have access to the box itself. I just have the box, right? So I don't actually have the root password, but it lets us read this file, and that's because that's the intention of this, right, is to practice this. So you could try with etc password, it'll fail. You could try it with etc shadow, it'll fail. This one, it lets you read just fine. Not sure why, but just forewarning, that's what that is. But we're essentially, with this is the file we want anyways. We're going to open up the etc password.txt file for reading, and once we do that, we're going to read, and we're going to tell it to read a certain byte, right? So in this one, we're going to tell it to read character position, right? So we're going to start with character position. Character position is currently 1. And then once we do that, where is my, there it is, okay. And then we're going to give it a array. So we're going to say character position -1. And we'll go into why that works in a second. And then equals. And then we're going to give it the character that we want. So we're going to say when we're in this position, right? So this is going to give us the current character in that position. It's going to read up that character. Now we're going to say, is it equal to this letter that we have, right? So if we wanted to, we could change this to letter. That might make a little more sense. That's fine. So does it equal this letter? And once we have that confirmation, we're going to tell it if it does equal this letter, and time.sleep. This is why we had to import sleep, or time, sorry, 2. Okay. So again, we're going to send it instead of an IP address. We're going to give it this semicolon. We're going to tell it to open up Python. Once it opens up Python, we're going to say, I want you to import time. I want you to open this file and read this file, or this character, right? So we're going to say, give it position 1. We want to read the first position. And then in here, character position -1 equals letter. We're going to say, does that letter equal the letter that we're giving it, right? So the first letter would be A, and then time.sleep. So if you notice here, we have another one of our little escapes, just so that we can bring up sleep, because it also blocks on sleep. So now when we run this, which we'll do in a second here, we're going to walk through it, and it'll make a little more sense what we're doing and why it works. So we're going to say if t.time minus, what do we say, current time is greater than or equal to 2, right? So we said when it's positive, sleep for 2 seconds, right? So if the letter is in fact the letter that we want it to be, go ahead and sleep for 2 seconds. If it's greater than 2, or greater than or equal to, sorry, Then we're going to say, where is it? Partial string. And then we're going to give it the letter equals letter. So we're going to keep adding onto this partial string, right? So this partial string is going to get bigger and bigger as we confirm what the letters are. And then we have to increase the character position. So character position plus equals 1. Whoops. So character position is supposed to equal 1. So this means we're going to go to the next character that we're looking for, right? So then you can see here character position. Well, now instead of being 1, it'll be 2, and then 2 and 3, all that good stuff. It'll just keep going until it gets to the end of the file. We're going to increment that by 1, and then we're going to print the current partial string. And then we're going to break, and we're going to do the whole loop all over again, right? And then we'll do if the letter equals 0, right? So if we've tried every possible combination and we got to 0, and it's still wrong, then we're just going to say, where is that? Found equals 1, just so we can break, and then break, right? All right. So the reason we need this is because eventually we're going to get to the end of the file, and it's going to return an EOL or EOF, which we don't account for in here. We just account for letters, right? So EOF just means end of file. So once we get to 0, we don't want to keep reiterating over every letter. We already know it's not that letter. So once we get to 0 and it's still not the letter in question, then we know we've probably hit the end of the file. So that's why we're doing that. We're going to make found equal to 1. The reason we're going to do that is so that we can break out of this while loop. And then we're just going to break and it'll cancel the whole thing. So we will go ahead and do a debug on this. And this box is a little wonky. Sometimes it works, sometimes it doesn't. I have a script that'll work perfectly on. So if it doesn't work on this one, we will walk through that one too. All right. So our first letter we're going to try is the letter A. We're going to get the current time, and we're going to send that, right? So we have get target, and the target we're going to pass is that whole command. We're giving it the character position, which is 1. And then we're going to say, is the letter in this position equal to A? And if it is, sleep for 2 seconds. So you saw we got an immediate response, right? So because we got that immediate response, oh, that's probably, hold on a second. I think it's because I've been debugging it, so that's probably why. Yeah, so you can see, because it's getting the current time right now, right? But you can see what it's trying to do. So let me actually rerun this, and we'll go to here. We'll break on this. So we saw how that worked. So we're actually just going to debug it and wait for positive or negative responses. So it's going to try all these letters. And actually what we can also do is else. And we're just going to say print tried, and then we'll give it the letter. This way we can see all the times it tries, right? So you can see it's trying all these letters until it gets a response. And then we got a slightly longer response on E. So we know that the first one is E, right? So it's going to add that to the partial string. You can see the first letter is E. We're going to increment the position by 1. So now character position instead of 1 is equal to 2. You can see that here. It's going to print out that letter for us. We can see that in the console, E. And then it's going to break and do it all over again, right? So now we'll wait for the next one. It's going to try all the letters again. What's the second letter going to be? And it's just going to keep doing that over and over again. And you see we got F for the second letter. And we'll just keep doing that until we get a positive response. And do we get the whole file, right? So you can see the next one's 7. And now I'm going to remove these breakpoints except for this one. And we're just going to let it go, right? So you see we got EF7. And if we come up to here, we got EF783. And it's just going to keep going, keep going. And it's a lot of text, but when it's done, we'll have the whole file. Still going. And what's important about this to note is, right, we had a lot of different things in place. So again, I would have loved if I had a little more time. I think it would have been great to kind of show you like how I went through and said, yeah, I can't use this. I can't just type Python. I can't just type sleep. And I can definitely show you that after. That's why it would fail. But there's a lot of testing that goes into this, right? So when you get onto a client environment and you find a machine like this, if you find something that's written in PHP, it's always great to check and see if you can do something like this. But it's always important also to figure out, like, I can't do it this way, but that doesn't mean I can't exploit it at all, right? And that's what a lot of this is, and that's what this box was really great for, is kind of showing you how to get around things that are in place to prevent you from breaking in, right? I was still able to get what I wanted. So you can see we got here, we got all the way through all the alphabet. We have our entire file password, right? So this is the password to get onto the box, technically, quote unquote, for the root user. And we were able to enumerate that using essentially PHP's weakness, and then executing code directly on the machine. And we can print through here, but you can see what it's doing, right? It tries every single possible combination. It got the whole file, and then it read all over again, went through all the lowercase, all the uppercase, all the numbers, and it said, I still didn't find it, so that must be the end of the file. If we really wanted to, we could add in space, because maybe there's a space in there and a bunch of other content, but that's not really what we're trying to do here, right? We already knew it was not going to have any spaces or anything, because it's just a like a CTF type box. But now if I go ahead and I make a simple change, right? Let's say I remove this, right? And I'm going to leave that try in there. You can see we get immediate fail, right? This took a lot of trial and error for me. So that one failed. And then also, if I remove it from here, we got another fail, right? We got no positive responses. And that's because once it gets to that machine, it's taking what we gave it, it's putting it directly into the command line, well, it's trying to. But before it does that, it's going to read over it. There's some sort of firewall rule or something in place that says, is what I'm seeing bad? And a lot of times, the only way that something, especially on Windows machines, the only way that it really knows if something is good or bad is what's called static analysis. It just looks as it is. It says, given what I see, is this bad? So it's specifically looking for words like Python 3. It's specifically looking for words like sleep, because those are often used in attack combinations, right? So being able to find ways to break that up is really important, right? Because before I got to figure out that sleep and Python were both bad, I was also trying it on time. So I might add like this here on time, and that still wasn't fixing it. So there's a lot of trial and error that went into this. But this is very common, especially in web apps, or web app, when you're trying to do bypass WAFs and all that stuff, right? So a lot of times you're going to attack the application, which is what this is doing. But then you have to think about, if they're using Cloudflare as a provider, not only do you have to do this to the application, but you also have to bypass Cloudflare before you get to the application. So there's even more that goes into this. Maybe you break it up and make it look like bytes. Maybe you use binary strings instead. Maybe you tell it to do something entirely different on the other end. You can do with a lot of these commands, if you use SQL injection or command injection of any kind. You can also make it take characters and then convert them back into letters. There's a lot of crazy stuff you can do. But this is just kind of like a really simple example of taking pen testing, using programming, and programmatically breaking down something, attacking an infrastructure, and getting something out of it that it wasn't supposed to be able to let you to do, right? So this would be an example where I would show this to a client. I'd say, yeah, you have all these safeguards in place, but you missed one, right? So my one that you missed would be like, you were looking for the word sleep, you were looking for the word Python. You could account for things that could be used to break those up, right? So maybe this, I could also in PowerShell do something like this, right? So maybe breaking up that way. But there's a lot of things that the security people miss because they're looking for very specific attacks, right? But it's kind of like an arms race, Cold War style, right? Like you might come up with one thing and then it stops me for a while, and then I come up with another one. You have to keep going, right? So it's not really good when you're talking to, like, on defense side, to look for rules that specifically look for words like Python. You have to be a little more creative than that, right? Like once it's done and I put it all together, does it say Python? That's important. But if you're looking at it and says I'm looking for Python, it's probably not the best. So hopefully this example made sense. I prefer showing stuff like this rather than web app stuff, because it's definitely my strong suit. But like I said, I can share this machine if you want to play with it. But there's plenty of stuff like this on like VulnHub. Like I said, you'll find stuff like this in labs on Hack the Box and Try Hack Me and a lot of stuff. So what questions do we have? I know that was probably pretty fast and maybe not everybody's forte, but hopefully I can explain that. How hard would it be to make your own OS using Python? I mean, if you want to start with another OS first, probably not that hard, right? So if you took like Ubuntu or Debian 12 or something like that, and then you just started using Python to make a Linux flavor, I don't think it would be that bad. It'd be more than I want to do. Kudos to you for doing it, but I don't think it would be that bad. If you want to run cyber business, how would you go about getting new clients? You'd have to do what I hate, which is marketing. A lot of times word of mouth isn't enough, right? So I have a lot of clients and a lot of people I used to work with, and that's how I get a lot of my business. But a lot of times you also need to just put yourself out there. You need to make marketing ads. You need to reach out to local businesses and see if they need your services, that kind of thing. And it really takes getting out there and showing everybody, that you're capable of doing these things. What coding software do I use? You're using CS50. I'm not familiar with CS50. I use JetBrains for a lot of things. VS Code is very good for other things. So VS Code I prefer for things like C, C Sharp, C++. JetBrains for everything else. I've heard of Windsurfer, which is very new, and it's a new style of AI assistance. So you saw the one I had where it just kind of auto completes based on what it learns from me. I like that for things like if I put the word letter, it just knows that I want the entire alphabet. So it depends on how much assistance you want. I learned on probably the worst IDE ever, which was that like NetBeans or whatever they called that. I hated that thing, but that forced me to kind of get to know the packages better myself. What other questions do we have? Like I said, if you have any questions about this, I'm happy to help. So, what is my favorite thing about my job? Research, probably. I really enjoy looking deeper into things. There's people out there that just like to use other people's code, and then there's people out there that like to build people's code or build the code. And I'm definitely that second person. And a lot of times that entails just being willing to look further into things than most people. And so when somebody not only appreciates that, but also is willing to pave the way or pay for me to do those things, which makes it easier for me, then that's probably my favorite part of my job is just sitting there and trying things and throwing stuff at the wall until it sticks, and then being able to show people how it works. So. What is the hardest project I ever worked on? Oh boy, I had one earlier this year. It was a medical system, and it was very well secured, and I was getting nowhere. We had about a week and a half to actually do the testing. I was on the second to last day, and I still had almost nothing. I found a really cool way around a feature they were using. They had like a system that was like a third-party device, so I was able to use that device to get other things. And once I got that other information, I was able to dump that box, and essentially ended up going around the entire environment, just dumping about 150 hosts. And then finally, I found something useful, and I got the entire environment. But that was probably the most difficult one. Is it's never a question of like if we're gonna get it. It's usually like when are we gonna get it? And so this one, I honestly felt like I wasn't gonna get it. And then the second to last day, I made some headway. But that was probably the toughest system I've ever worked on. What sources do I recommend for coding and cybersecurity? So for programming specifically, I always recommend what's that called? Codecademy. And then once you've gotten through and you understand the basics from Codecademy, which is what I use when I try to learn a new language, then you can go into things like HackerRank. And HackerRank is really good for just improving your skills and kind of getting up the ladder. It teaches you how to do things outside of the box. And then for cybersecurity, just reading up a lot. You're not going to be able to get your hands on a lot of these devices that you need to test. So a lot of times just reading up on it, it's really good. Building your own stuff, finding open source software and just reading it and understanding how it works is probably the best way for cybersecurity, because that's what hackers are doing. So you might as well do the same thing. If you wanted to add spaces to the check-in sequence, how would you go about doing that in any other special characters? Yeah. So if I wanted to add a space, it would, quite literally, I would just do this. If I wanted to add a new line, I would do this. If I wanted to add carriage return, I would do this, right? So these are all valid characters. And that's basically how you do it. So when you got the actual feedback back, this wouldn't show up as anything. It would just, once you printed it, would show it, but it is actually accounting for this character. It's looking for that character. The other thing you wanted to do, and instead of this, if you wanted to, and Golang is a little better for this, you could actually use the ASCII code, right? So A has its own ASCII character, B has its own ASCII character. So you would just take this and you would instead start from, I think it's 151 all the way through 197 or something like that, is like the whole alphabet, and then like some special characters. So instead of using letters, you would use numbers, and you'd use those numbers and say, hey, if you get the character with this position, you convert it into an ASCII number. Is it this number? That would be probably a better way to check efficiently if this was a new line or something like that. I work on a Linux Debian computer a lot. This is very similar to Linux client codes. Yeah, so this the whole point of this, right? Is this box that we're attacking is a Linux computer. The person built this web application that all it does is it gets an IP address from this field and it pops it into a Linux shell, and then it runs it, and then it comes back and says, yeah, I did it or I didn't do it. So that's a lot of times what this is, and that's what I like to call lazy code, because you have almost no control over that. You're kind of hoping your operating system will catch it for you. So what other questions do we have? Doesn't have to be about this. It could be something completely different. If you wanted to add spaces and chunks, how'd you come about doing that in any of those special characters? Yep, so I already went over that one, right? So like I said, you could do the ASCII characters, or you could just add literally a space in here, or whatever else you're looking for. All right. Well, I appreciate everybody showing up. Again, sorry for being late in that first one. If you do have any other questions, I'm willing to hang out until the time's up. So feel free to put them in here. Is codecamp.org the same as Codecademy, or is one better than the other? So personally, I don't recommend W3 schools. I can't remember the one I use. I think Beldung is the one I prefer. If you're looking up like, it's almost like a wiki of how to do things. I've never used codecamp.org, so I can't say if it's better or not than Codecademy. What I like about Codecademy is it's really good at the basics. So it's on you to expand from there, and that's why I like things like HackerRank. So yeah, Beldung is Baeldung, I believe is how it's spelled.
Well, Evan, thank you so much for a great session. I think that we can let folks go to their next one. So we appreciate everything that you taught us today and hope that you have a good rest of your day.
Appreciate it. Thank you.